In this video, we continue our journey towards building a development environment for web development. In the last video, we constructed a Docker Compose file to manage our whole project, so we no longer have to issue separate commands and bridging the network between the Docker Composers over the host network. So everything could be easily started and stopped via the Docker Compose command. In this video, we continue this journey towards the complete environment by making a continuous integration pipeline, and we're going to use GitLab for that. And you might wonder why we use GitLab rather than GitHub, but GitLab is open source, and that's one of the key values that we estimate these services by. And also, the continuous integration platform on GitLab is far more coherent, mature, and in all ways better than what you find on GitHub. The ideas you see in this video, though, are not all that different from GitHub, and you would be able to transfer the key ideas and make some minor syntax adjustments to make it work on GitHub if you wanted to do that. What we have so far is we have this Docker Compose file that runs our application with network separation between the app and Nginx and the app and the DB service. So that's what we have now. We also have persistence so that our information is stored across multiple runs of the service. So let's go ahead and get started. And if you like these videos, please like and subscribe. So we're going to continue where we left off last time. And in this video, we are going to start the GitLab-ci.yml file. And this is the file that is going to contain our GitLab pipeline, or our continuous integration pipeline. So this is a YAML file, and as you are used to already, these files are very sensitive to indentation because that is what forms the hierarchy in the file. So take good care of formatting the file correctly. Don't forget that you can find all the source files on the engenie.online website if you don't want to type the whole thing yourself. So in our GitLab CI file here, the first thing we are going to do is to declare two stages. And the stages are going to be run sequentially, that is like one after the other. And the first stage has to succeed in order for the next to begin running. Otherwise, it will not start. So we are going to do first a static stage, and then we're going to do a dynamic build stage, or dynamic stage maybe, just so that we can easily tell what is a stage and what is not a stage, because that might not be all that clear looking at the file. So having that in place, we are going to start working on the first job of our static stage. So unlike stages, the jobs within each stage are going to run in parallel. So if we make two jobs under the static stage, these two jobs will start at the same time. But again, they will not continue until the next stage, until everything under the previous stage completes successfully. So let's dig into it. So the static stage here, or the static shell rather, that is the name of a job now. And we make it part of a stage by putting it here. So static stage, that makes the static shell job part of the static stage. And it's going to run within a Docker container. So we need to provide the name of a Docker image here. So the image, and that looks just like in Docker Compose, will be alpine latest. And then we have a before script here. And I can't spell today. Script, S-C-R-I-P-T : yes. So the before script here is going to set up the environment for the next part of the script. So what we're going to do in here is to install any dependencies we might need. So apk add, because it's a alpine based image, we are going to need shell check, and we're going to need YAML lint. And these packages exist within the Alpine package repository, so we can install them via apk add. That's all good. The next thing we have here is the script section. And in the script section, we run the shell check, and that's going to run on all .sh files. And next we are going to have YAML lint, and it's going to run on all YML files. Okay, that doesn't look all that crazy. You might notice that this is almost like a shell script, and that is not by coincidence. It is designed that way. So with that in place, we can continue until the next stage. Oh, sorry, the next job. And the static Python job will also be on the static stage. We're going to need another image here. So the image here is going to be Python 3.14-4-Alpine 3.22. That is the latest stage at this time and place when I'm recording. That fits our environment, so we'll be using that one. The before script here, we are going to need the UV tool, so apk add UV, and we're also going to need Git, and you'll see why later. And this is going to run with access to our repository files. So we can use UV sync here, and it will install all the packages listed in our repository dependencies managed by UV. And then we will run UV pip install pip audit. And you might wonder what is the difference between UV add and UV pip install. So UV pip install is for ad hoc installations. So this is not going to be written to the dependency file, it's just going to be installed into the environment. We are also going to say UV pip install, and we are going to access via GitHub this time, so https://github.com/psf black. And that is because the black tool does not have a PyPy package that we can install using UV pip install. The script section here is going to then use these tools. So UV run pip audit, and the pip audit tool is going to look at all our packages in the Python environment and see if they have any security vulnerabilities, because we obviously don't want to roll out our image with any vulnerabilities already in it. So that will take care of testing that. Then we will run UV run black, and that will run a linter on the Python files and check if everything is correctly formatted according to Pepper 8 standard within the Python Python ecosystem. So with that, we are going to have reasonably sensible Python files correctly formatted. Okay, so let's continue to the more interesting part, namely the dynamic stage. So we are going to make a job on the dynamic stage. I'll just save the file here. So on the dynamic stage, we're going to make a dynamic build job. And that will belong to the stage, dynamic stage. And the image we're going to use here is Docker:/latest. And the Docker image is an image that contains the Docker tools and Docker Compose tools also. So that will be fine for what we need here. Let me just scroll up a bit. So the Docker image comes with a service that we need to enable. So services, we need to list that here, and that is called Docker::dind, Docker in Docker. And Docker in Docker enables us to run Docker within a Docker container, because if you think about it, the Docker image here is a Docker image, so we're launching a Docker container, but we need to use the Docker tools within this Docker container. So it's a little bit meta, but that's actually what's happening here. You will see it in a few seconds. So the before script here, we need to do only one thing, and that is to log into the Docker registry where we're going to save our Docker image in a minute. Because we're going to write a very long command, there's this trick you can do here. So we make a pipe character in the first line and then press enter, and then you can see that I'm placed directly under the pipe character. And this pipe character is not the normal shell scripting meaning of a pipe character. It's a YAML format that allows me to write a multi-line string below this pipe character. So it's a YAML feature, not a shell script feature. So we are going to echo the password so that we can log into the registry for the Docker images, and that is stored in an environment variable called CI registry password. Like that, and that should be like that. And again, we don't really need to see it on the terminal or the log. So what we're actually going to do is to pipe it into the Docker login command. So a pipe character here, and that is a normal shell scripting pipe character. I'm going to put a backslash here, and that is a shell scripting feature that allow me to come to the next line and continue the command, because this is going to be a very long command. So the password will be piped into the Docker login command. And I'm going to continue on a new line again. So Docker login, and we are indicating here that it should take the password from std_in, and that means that Echo here will put the CI registry password on its own standard out, and we pipe that into the standard in of Docker login, and that is how the Docker login command will have the password available to it. Seems a little bit weird maybe, but that is the recommended best safe way of doing it. We also need to provide a username. We do that with the -u command, and again we need a environment variable here, which is CI registry password. Sorry, password, not password, of course, user. So this will provide a valid username for the pipeline. And then we are going to give 2 dashes here, and the 2 dashes indicate to the shell command that no more options are going to follow. What is going to follow next is a parameter. So the parameter here will be the name of the registry that we are logging into, and that will be CI registry, like that. And that's kind of a mouthful, so let us just inspect it again. So the echo command pipes the CI registry password into the Docker login command. It reads it from the standard input. It sets the user to CI registry user and signifies the CI registry as the registry we are going to log into. So that should take care of logging us into the registry. So the next thing here we are going to define is the script section. And we're going to do 3 things here. First, we are going to build an image. Then we are going to run Docker compose up in test mode to test that everything works fine. And then if everything works fine, we're going to push it to the registry that we have just been logged into. Right, so the first command here will be Docker build. And we are going to use a option here called pull. And you might wonder, why are we pulling the image from the registry if we're going to build a new image immediately anyway? And that has to do with the way that Docker handles layers, because if you remember, it will only rebuild a layer if it has actually changed. And this way we can potentially save a lot of work by reusing images, layers in images that has not changed. So that's a pure optimization, and if I removed pull here, it would still work, but it would be less optimal. So we're going to tag it, and the tag will be provided also within a environment variable that will be CI registry image. And latest. And we put a dot here to indicate that it will find the Docker file in the current directory. So that is the project root directory. So far so good. Now that we have built our image, we can try to actually run it with Docker Compose up. So we set the runtime environment variable here to not development but test mode. And then we run Docker Compose up, And we are going to specify a few options here. So the first one is abort on container exit. And what that does is that immediately when any service exits, so if a Docker container exits, it will take down the whole Docker Compose. And that is because if you think about it, normally when we run Docker Compose, it will run until we take it down manually. And that is not very smart when we are running on the CI pipeline, because we can't really interact with it. So we needed to not sit and waste the pipeline minutes waiting for requests that will never appear. So whenever a service exits, it can take down the whole Docker Compose. The other option we are going to give here is exit code from app. So the exit code from option allows us to specify the name of a service, in this case app service. And if you remember, when a shell command or shell script exits, it will exit with exit code 0 if everything went well. And if some error happened, it will be a non-zero value. And because we want our pipeline to know whether everything went fine testing Docker Compose, we have to propagate this exit code from within the Docker container to the CI pipeline. And that is exactly what this exit code from app does. Remember, the error will happen inside the Docker container, which the pipeline cannot see. And so we need this option in order to break the pipeline if anything fails. And if nothing fails, we can continue here and say Docker push. And what we want to push is CI registry image. Latest. And that will only happen if everything goes well, if no error happens. So if some of our test fails, the line above, this line here, will exit with some exit code non-zero, and that will exit the pipeline immediately rather than going to the next step here. This way we ensure that we are not going to push an image to the pipeline with some kind of error in it. And the image on our registry should always be a good image.